Right? How do you find min term 1, 2, 3, 4, 5, 6, 7 equal to x1 or x2, x3? So first thing to do is write out. So I'm going to just write out all the term first and add the inversion where it is needed. We have total 7. Okay, that's 1, 2, 3. 3 is 0, 1, 1. 4, 5, 0, 1, and 1, 0, 1, 5, 6, and 7. Okay, so let me show you how you could guide your implementation. Okay, we are using this as a guidance to help us see where we're going. So this is in fact the K-map. Okay, in fact this right here, okay, and that right there. Interestingly, this give us x1, this give us x3, and this give us x2. Okay, so so the idea is we should be able to find terms that we need to help us come up with x1, x2, x3. Okay, so another quick example, if you have this, if you have two variable x, y, okay, if a function given to you include x naught, y naught, x, y naught, x naught, y, and xy, it's in fact equal to 1 because you have written out all the min term, all the cases given to you, so g is equal to 1. So the idea is potentially we could find x1 with something, x2 with something, and x3 with something. Okay, where all the case for the first one, where all the cases for x2 and x3 are all spelled out. For the second case x2, where all the cases for x1 and x3 are spelled out, and for x3, the third one, where all the cases for x1 and x2 are spelled out. So so now we need to look for things. Let's start with x3. Now we need to look for things that has x3 and with all the cases spelled out. Okay, x3 with all the cases spelled out. Let's look for x3 with all the cases spelled out. Okay, so we could be using, let me change color. Okay, could be using this, and that. Okay, so if you have that, so you have x3, x1 naught, x2 naught, x1 naught, x2, x1, x2 naught, and x1, x2. See it? So now we'll look for x2. Okay, if you look for x2, you will see this x2, that we're going to use these terms again, and that, and that. Okay, so x2, say maybe x1 naught, x3 naught, x1 naught, x3, x1, x3 naught, x1, x3. Okay, and the last one, for sure that we're going to have to reuse this. In fact, we just reuse the last 4 term. If you use the last 4 term, you have x1, x2 not, x3 not, 2 not, x3, x2, x3 not, x2, x3. Okay, see inside this, all this, inside all the cases, it's all the cases. This actually go to 1, this actually go to 1, this go to 1. So it's the same thing at x1, x2, and x3. You could have used K-map, but the problem statement says that you have to use algebraic manipulation. So if you work it out this way using K-map as a guidance, it is an okay method, but you have to work it all out. Okay.